Welcome to The Explainer. Today, we're diving headfirst into one of the most mind-bending and, frankly, revolutionary technologies on the horizon, quantum computing. So, let's just start with a huge question, because that's really what this is all about. Quantum computing is about tackling challenges that we once thought were completely unsolvable. We're talking about things like designing brand new materials, atom by atom, or cracking today's strongest encryption. Problems so massive, it would take a normal computer literally longer than the age of the universe to solve. So, what kind of impossible problems are we really talking about here? Let's take a look at the incredible potential that has scientists and whole industries just buzzing with excitement. Well, for starters, imagine being able to simulate complex molecules with perfect accuracy. This could help us discover new medicines and materials. A task like this would take the best supercomputers we have today thousands of years. But a quantum computer? In theory, it could do it in minutes. And the applications are just vast. We are looking at massive breakthroughs in everything from finding new materials for green energy and streamlining global logistics to creating communication networks that are literally unhackable and building way, way smarter AI. This is the quantum promise. Now, to get all this done, we can't just build a faster version of the computers we already have. No, we need a completely new kind of machine, one that plays by the strange and kind of wonderful rules of quantum mechanics. The power of these machines, it scales in a way that's just hard to wrap your head around. Like the slide says, the growth is exponential. To put that into perspective, adding just one more quantum component can literally double the machine's computational power. Think about that. So, let's pull back the curtain. Yeah, it might not look like your laptop. Actually, it kind of looks more like a high-tech chandelier, right? But inside all that elaborate casing, this machine is operating on the fundamental laws of the universe. Okay, let's dive into this a little deeper. The secret to all of this incredible power isn't in transistors or circuits, not like we're used to. It's in a little something called a qubit. So a qubit is the quantum version of a classical bit, the ones and zeros that power all the tech we use today, but it comes with a superpower. Now, this slide here gets to the absolute core of it. A classical bit is like a light switch. It's either on, a 1, or it's off, a 0. Simple. A qubit, though, thanks to this quantum trick called superposition, is more like a spinning coin. It can be a 1, a 0, or a combination of both at the very same time. And when you link these qubits together, you can explore this huge landscape of possible solutions all at once. That's the secret sauce to their incredible speed. And this chart, wow, this shows that explosive growth perfectly. Just look at these numbers. At 30 qubits, you've got the power of a pretty good laptop. But jump to just 50 qubits and you're already rivaling the world's top supercomputers. And then, at 250 qubits, you could theoretically represent more states than there are atoms in the known universe. That is just mind-boggling. And hey, this isn't just theory on a blackboard anymore. Right now, there are major projects happening all over the globe to turn this incredible potential into real-world industry-changing applications. For example, you've got the German-funded Aquas project. They're using quantum simulation to speed up the discovery of new materials we need for clean hydrogen production. That's a huge piece of the green energy puzzle. And it's not just about materials. The AutoQML project is all about making AI smarter by using quantum methods for machine learning. And they're working on really practical stuff, from predicting when a car might fail to optimizing laser cutting in factories. And then you have projects like Q-Challenge, bringing together huge players like BMW and Siemens. They're trying to crack these immense logistics and production puzzles. The kinds of super complex problems that are absolutely essential for our modern global economy. Okay, so if this technology is so promising and all these incredible projects are already underway, what's the holdup? What are the risks and the challenges here? And that's a totally fair question. The honest truth is that building a useful, large-scale quantum computer is one of the greatest scientific and engineering challenges of our time. So the single most crucial point is that qubits are fragile, incredibly fragile. Their delicate quantum state can get completely thrown off by the tiniest vibration, a slight change in temperature, or any stray electromagnetic field. This noise creates errors, and a lot of them. So the grand challenge right now is building a machine that can correct these errors as they happen. Scientists call this a fault-tolerant system, and that's the absolute key to making them reliable.
But the good news is, brilliant teams all over the world are tackling these challenges head on. They are exploring different ways to build these things, like trapping single atoms on a microchip or creating these complex superconducting circuits. Each approach has its own pros and cons, but they're all pushing towards the exact same goal: a stable, scalable quantum computer.
And this really gets to the heart of it: the journey to a useful, fault-tolerant quantum computer, one that can actually handle its own mistakes. It's a marathon, not a sprint. We're definitely still in the early days, but every single breakthrough brings us one step closer to a future that could be completely reshaped by this technology. In the end, the spirit that's driving this whole global effort is maybe best captured by this wonderful quote from Pippi Longstocking. It's just the perfect mix of boldness, optimism, and a real willingness to try the impossible. And let's be honest, when you're trying to build a new kind of reality, that is exactly the spirit you need. Thanks for watching.